All right, chapter 24, part 3, groundwater mining. This is referring to withdrawals from aquifers that exceed any possibility of recharge. So this means, like we're always taking water out of the aquifer, right? We're showering, we're washing our clothes, maybe you're watering your garden. There's those kinds of things. But when we withdraw so much from the aquifer that it's never ever going to be replenished, we refer to that as groundwater mining. So this has been done in the United States, specifically the arid West and Southern California. And what happens is the groundwater levels drop. And essentially, one of the things that can happen from that is sinkholes. So it's hard to imagine, but there's the groundwater that's helping support the earth beneath our feet. And if that water is not there, then it can cause essentially the ground to collapse, whole homes to fall into big, gigantic holes. The trouble with groundwater mining is we have whole municipalities of people living in areas that don't really have the possibility of groundwater in the future. So one of the things that we're going to have to do is essentially build a series of canals so that we can move water around to where people are living. So this is obviously going to put a pretty big strain on our budgets, and it begs the question, well, maybe humans should move to where the water's at. Now, I should tell you that the majority of the Earth's population lives on the coast, right? Sounds like, a good place to live. But the trouble is at the coast, we're looking at salt water. So the only way we can drink salt water is through desalinization or desalting the water, which is very, very expensive. So we've got to think about human populations and how to secure plenty of drinking water that's free of microorganisms and free of chemical pollutants. Okay, one other cycle, just to kind of give you the flavor of it, and also this ties directly into one of the big things that we talk about, which is increased carbon dioxide in the atmosphere. Okay, so let's start with what you know. What you know, remember, producers have chlorophyll. Chlorophyll can capture photons of light from the sun in the presence of a pigment called chlorophyll, and then also in the presence of CO2, can make oxygen and carbohydrates. So that's great. So one of the main ways that we're transporting carbon is from the food chain. So we're transporting carbon from our producers or our plants directly into our primary consumers, and that's being passed on, secondary consumers, and so on. So that's super awesome. So we know that the process of photosynthesis is a way to take out CO2 in the air. Now, if we do deforestation, so we remove plants from the earth to build roads or malls or subdivisions or all the things, or if there's a flooding and so on or a fire that's wiped out the plants in the area, then we have lost a huge sink for carbon. So carbon dioxide then remains in the atmosphere. Now, also, by being alive, plants are putting some I don't know why that says that. That's silly. Plants do respiration, of course. It's not a very big amount that's going back into the atmosphere as CO2. Most of it they're using. But we do know that as animals, we use oxygen and glucose, and we're going to make carbon dioxide. So by exhaling, we are returning some of that CO2 to the atmosphere. Now, down here in this detrital layer, so the detritivores and our decomposers, well, what are they doing? Oh, right, they're degrading away organic matter and making, that's right, CO2. So all these organisms are making CO2, which goes back to the atmosphere. Some of the CO2 can be sequestered as bicarbonate in the ocean. And of course, it can go through a transformation and form calcium carbonate. So it can get locked up in sedimentation, but there's an increasing amount of CO2 in the atmosphere. Why? Because fossil fuels actually represent a sequestered, buried form of carbon that was essentially sequestered away during the Carboniferous age. If you're taking a look at the history of the Earth, so we call these fossil fuels. The name kind of implies it came from dead old, things. and under intense temperature and pressure form this fuel, okay? So that fuel is full of carbon. So what do? Well, we like to have on-demand sources of energy. So we like to have gasoline for our cars, and we have natural gas or home heating oil or coal to heat our homes and all these things. And so we are burning more and more and more fossil fuels. And as a result, we are unleashing what was sequestered carbon dioxide and putting it back into the atmosphere. Of course, this is showing us trucks and factories and so on that also burning fossil fuels and releasing carbon dioxide. Here's a fire. When we have fires, we're releasing a tremendous amount of carbon dioxide. So again, we have an idea of how humans might be altering the carbon cycle through deforestation and use of fossil fuels, compromising our land and so on in this carbon cycle. So we know this increased amount of CO2 in the atmosphere, essentially under the action of the greenhouse effect, is locking in heat in our atmosphere. And so we are seeing, historically, an increase in global temperature or global warming, and as a result, we're seeing that climate is changing all over the world. I'm not going to talk about the nitrogen cycle. But certainly there are some issues with nitrogen. For example, burning of fossil fuels, we're adding more nitrogen and sulfur dioxides to the atmosphere. And so that can come back down to the earth as rain, sleet, or snow. And acid rain, as its name implies, is lower in pH. So when that is going directly into our lakes, then we're changing the acidity of our lakes. Also, this acid rain affects forests. It weakens the infrastructure of trees, and it actually erodes stonework, like you see here in Part C. So you can go into any cemeteries and see essentially some eroding away of those statues because of acid rain or acid deposition. Okay, well, we got one more chapter, chapter 25. See you soon.